Isaac Newton. Part 3 of 3, Theology. Religious views. Although born into an Anglican family, by his 30s Newton held a Christian faith that, had it been made public, would not have been considered orthodox by mainstream Christianity, with one historian labeling him a heretic. By 1672, he had started to record his theological researches in notebooks, which he showed to no one and which have only recently when. They demonstrate an extensive knowledge of early church writings and show that in the conflict between Athanasius and Arius, which defined the creed, he took the side of Arius, the loser, who rejected the conventional view of the Trinity. Newton recognized Christ as a divine mediator between God and man, who was subordinate to the Father who created him. He was especially interested in prophecy, but for him, the great apostasy was Trinitarianism. Newton tried unsuccessfully to obtain one of the two fellowships that exempted the holder from the ordination requirement. At the last moment in 1675, he received a dispensation from the government that excused him and all future holders of the Lucasian chair. In Newton's eyes, worshiping Christ as God was idolatry, to him the fundamental sin. In 1999, historian Stephen D. Snobelin wrote, Isaac Newton was a heretic, but he never made a public declaration of his private faith, which the Orthodox would have deemed extremely radical. He hid his faith so well that scholars are still unraveling his personal beliefs. Snobelin concludes that Newton was at least a Socinian sympathizer. He owned and had thoroughly read at least 8 Socinian books, possibly an Arian and almost certainly an anti-Unitarian. Although the laws of motion and universal gravitation became Newton's best-known discoveries, he warned against using them to view the universe as a mere machine, as if akin to a great clock, he said. So then gravity may put the planets into motion, but without the divine power it could never put them into such a circulating motion as they have about the sun. Along with his scientific fame, Newton's studies of the Bible and of the early church fathers were also noteworthy. Newton wrote works on textual criticism, most notably an historical account of 2 notable corruptions of Scripture and observations upon the prophecies of Daniel and the Apocalypse of St. John. He placed the crucifixion of Jesus Christ at 3 April, at 33, which agrees with one traditionally accepted date. He believed in a rationally immanent world, but he rejected the hylozoism implicit in Leibniz and Baruch Spinoza. The ordered and dynamically informed universe could be understood, and must be understood, by an active reason. In his correspondence, Newton claimed that in writing the Principia, I had an eye upon such principles as might work with considering men for the belief of a deity. He saw evidence of design in the system of the world. Such a wonderful uniformity in the planetary system must be allowed the effect of choice. But Newton insisted that divine intervention would eventually be required to reform the system due to the slow growth of instabilities. For this, Leibniz lampooned him, God Almighty wants to wind up his watch from time to time, otherwise it would cease to move. He had not, it seemed, sufficient foresight to make it a perpetual motion. Newton's position was vigorously defended by his follower Samuel Clarke in a famous correspondence. A century later, Pierre-Simon Laplace's work Celestial Mechanics had a natural explanation for why the planet orbits do not require periodic divine intervention. The contrast between Laplace's mechanistic worldview and Newton's one is the most strident, considering the famous answer which the French scientist gave Napoleon, who had criticized him for the absence of the creator in the Mécanique Céleste. Sire G. Puis me passer de cette hypothèse. Sir, I didn't need this hypothesis. Scholars long debated whether Newton disputed the doctrine of the Trinity. His first biographer, David Brewster, who compiled his manuscripts, interpreted Newton as questioning the veracity of some passages used to support the Trinity, but never denying the doctrine of the Trinity as such. In the 20th century, encrypted manuscripts written by Newton and bought by John Maynard Keynes, among others, were deciphered, and it became known that Newton did indeed reject Trinitarianism. Religious thought. Newton and Robert Boyle's approach to the mechanical philosophy was promoted by rationalist pamphleteers as a viable alternative to the pantheists and enthusiasts, and was accepted hesitantly by orthodox preachers as well as dissident preachers like the latitudinarians. The clarity and simplicity of science was seen as a way to combat the emotional and metaphysical superlatives of both superstitious enthusiasm and the threat of atheism. and at the same time the second wave of English deists used Newton's discoveries to demonstrate the possibility of a natural religion. The attacks made against pre-Enlightenment magical thinking and the mystical elements of Christianity were given their foundation with Boyle's mechanical conception of the universe. Newton gave Boyle's ideas their completion through mathematical proofs, and perhaps more importantly, was very successful in popularizing them. Alchemy. Of an estimated 10 million words of writing in Newton's papers, about 1 million deal with alchemy. Many of Newton's writings on alchemy are copies of other manuscripts with his own annotations. Alchemical texts mix artisanal knowledge with philosophical speculation, often hidden behind layers of wordplay, allegory, and imagery to protect craft secrets. Some of the content contained in Newton's papers could have been considered heretical by the Church. In 1888, after spending 16 years cataloging Newton's papers, Cambridge University kept a small number and returned the rest to the Earl of Portsmouth. In 1936, a descendant offered the papers for sale at Sotheby's. The collection was broken up and sold for a total of about $9,000. John Maynard Keynes was one of about 3 dozen bidders who obtained part of the collection at auction. Keynes went on to reassemble an estimated half of Newton's collection of papers on alchemy before donating his collection to Cambridge University in 1946. All of Newton's known writings on alchemy are currently being put online in a project undertaken by Indiana University. The Chemistry of Isaac Newton, and summarized in a book. Newton's fundamental contributions to science include the quantification of gravitational attraction, the discovery that white light is actually a mixture of immutable spectral colors, and the formulation of the calculus. Yet there is another more mysterious side to Newton that is imperfectly known, a realm of activity that spanned some 30 years of his life. Although he kept it largely hidden from his contemporaries and colleagues, we refer to Newton's involvement in the discipline of alchemy, or as it was often called in 17th century England, chemistry. In June 2020, 2 unpublished pages of Newton's notes on Jan Baptist van Helmont's book on plague, De Peste, were being auctioned online by Bonhams. Newton's analysis of this book, which he made in Cambridge while protecting himself from London's 1665-1666 infection, is the most substantial written statement he is known to have made about the plague, according to Bonhams. As far as the therapy is concerned, Newton writes that the best is a toad suspended by the legs in a chimney for 3 days, which at last vomited up earth with various insects in it, onto a dish of yellow wax, and shortly after died, combining powdered to aid with the excretions and serum made into lozenges, and worn about the affected area drove away the contagion and drew out the poison. Legacy. The mathematician Joseph Louis Lagrange said that Newton was the greatest genius who ever lived, and once added that Newton was also the most fortunate, for we cannot find more than once a system of the world to establish. English poet Alexander Pope wrote the famous epitaph, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." But this was not allowed to be inscribed in the monument. The epitaph in the monument is as follows: H.S. E. Isaacus Newton, equi seratus, equi animi viprop divina, e planetarum modus figuras de cometarum semitas, oceanic estis, sua mathesi facem preferentia primus demonstravit, radiorum lucis dissimilitudinis, bacalorum que in nascentium proprietates, de quas nemo ante avel suspicatus eris, pervestigavit, natura antiquitatis, eris et scripturae, sedulus, sagax, vidas interpressit Dei o, majestatem philosophia seruit, asserduit, evangelii simplicitatem moribus expressit, sibi gradulentur mortales, estel tantumque extatis, nat. Exiv D, Atia D, Ad Mbexli, obiit XX mar mitexvi, which can be translated as follows. Here is buried Isaac Newton, knight, who by a strength of mind almost divine and mathematical principles, peculiarly his own, explored the course and figures of the planets, the paths of comets, the tides of the sea, the dissimilarities in rays of light, and, what no other scholar has previously imagined, the properties of the colors thus produced. Diligent, sagacious, and faithful in his expositions of nature, antiquity, and the Holy Scriptures, he vindicated by his philosophy the majesty of God mighty and good, and expressed the simplicity of the gospel in his manner. Mortals rejoice that there has existed such and so great an ornament of the human race. He was born on 25th December 1642 and died on 20th March 1720. In a 2005 survey of members of Britain's Royal Society, formerly headed by Newton, asking who had the greater effect on the history of science, Newton or Albert Einstein, the members deemed Newton to have made the greater overall contribution. In 1999, an opinion poll of 100 of the day's leading physicists voted Einstein the greatest physicist ever, with Newton the runner-up, while a parallel survey of rank and file physicists by the site PhysicsWeb gave the top spot to Newton. News scientists called Newton the supreme genius and most enigmatic character in the history of science. Einstein kept a picture of Newton on his study wall alongside ones of Michael Faraday and James Clerk Maxwell. The sea-derived unit of force is named the Newton in his honor. Woolsthorpe Manor is a Grade I listed building by Historic England through being his birthplace and where he discovered gravity and developed his theories regarding the refraction of light. In 1816, a tooth said to have belonged to Newton was sold for $730 in London to an aristocrat who had it set in a ring. Guinness World Records 2002 classified it as the most valuable tooth in the world, which would value approximately Ps 25,000. Who bought it and who currently has it has not been disclosed. Apple incident. Newton himself often told the story that he was inspired to formulate his theory of gravitation by watching the fall of an apple from a tree. The story is believed to have passed into popular knowledge after being related by Catherine Barton, Newton's niece, to Voltaire. Voltaire then wrote, in his essay on epic poetry, 1727, Sir Isaac Newton, walking in his gardens, had the first thought of his system of gravitation upon seeing an apple falling from a tree. Although it has been said that the apple story is a myth and that he did not arrive at his theory of gravity at any single moment, acquaintances of Newton, such as William Stukeley, whose manuscript account of 1752 has been made available by the Royal Society, do in fact confirm the incident, though not the apocryphal version, that the apple actually hit Newton's head. Stukeley recorded in his memoirs of Sir Isaac Newton's life, A Conversation with Newton in Kensington on 15 April 1726. We went into the garden, drank Thea under the shade of some apple trees. Only he, thus myself. Amidst other discourse, he told me he was just in the same situation as when formerly the notion of gravitation came into his mind. Why should that apple always descend perpendicularly to the ground? Thought he to himself, occasioned by the fall of an apple, as he sat in a contemplative mood. Why should it not go sideways or upwards, but constantly to the earth's center? Assuredly, the reason is that the earth draws it. There must be a drawing power in matter. In the matter of the earth must be in the earth's center, not in any side of the earth. Therefore does this apple fall perpendicularly, or toward the center. If matter thus draws matter, it must be in proportion of its quantity. Therefore the apple draws the earth as well as the earth draws the apple. John Conduit, Newton's assistant at the Royal Mint and husband of Newton's niece, also described the event when he wrote about Newton's life. In the year 1666, he retired again from Cambridge to his mother in Lincolnshire. Whilst he was pensively meandering in a garden, it came into his thought that the power of gravity, which brought an apple from a tree to the ground, was not limited to a certain distance from Earth, but that this power must extend much further than was usually thought. Why not as high as the moon, said he to himself. If so, that must influence her motion, perhaps retain her in her orbit. Whereupon he fell a calculating what would be the effect of that supposition. It is known from his notebooks that Newton was grappling in the late 1660s with the idea that terrestrial gravity extends, in an inverse square proportion, to the moon. However, it took him 2 decades to develop the full-fledged theory. The question was not whether gravity existed, but whether it extended so far from Earth that it could also be the force holding the moon to its orbit. Newton showed that if the force decreased as the inverse square of the distance, one could indeed calculate the moon's orbital period and get good agreement. He guessed the same force was responsible for other orbital motions, and hence named it universal gravitation. Various trees are claimed to be the apple tree which Newton describes. The King's School, Grantham claims that the tree was purchased by the school, uprooted and transported to the headmaster's garden some years later. The staff of the now National Trust-owned Woolsthorpe Manor dispute this, and claim that a tree present in their gardens is the one described by Newton. A descendant of the original tree can be seen growing outside the main gate of Trinity College, Cambridge, below the ruin Newton lived in when he studied there. The National Fruit Collection at Brogdale in Kent can supply grafts from their tree, which appears identical to Flower of Kent, a coarse-fleshed cooking variety. Commemorations. Newton's monument, 1731, can be seen in Westminster Abbey at the north of the entrance to the choir against the choir screen, near his tomb. It was executed by the sculptor Michael Rysbrack, 1694, 1770 in white and gray marble with design by the architect William Kent. The monument features a figure of Newton reclining on top of a sarcophagus, his right elbow resting on several of his great books and his left hand pointing to a scroll with a mathematical design. Above him is a pyramid and a celestial globe showing the signs of the zodiac and the path of the comet of 1680. A relief panel depicts Putty using instruments such as a telescope and prism. The Latin inscription on the base translates as, "Here is buried Isaac Newton, knight, who by a strength of mind almost divine, and mathematical principles peculiarly his own, explored the course and figures of the planets, the paths of comets, the tides of the sea, the dissimilarities in rays of light, and what no other scholar has previously imagined, the properties of the colors thus produced. Diligent, sagacious, and faithful in his expositions of nature, antiquity, and the Holy Scriptures, he vindicated by his philosophy the majesty of God mighty and good, and expressed the simplicity of the gospel in his manners. Mortals rejoice that there has existed such and so great an ornament of the human race. He was born on 25 December 1642 and died on 20 March 1726. Translation from G.L. Smith, The Monuments and Genii of St. Paul's Cathedral and of Westminster Abbey, 1826, i.e. I 703, 704, from 1978 until 1988. An image of Newton designed by Harry Ecclestone appeared on Series D sewn banknotes issued by the Bank of England, the last sewn notes to be issued by the Bank of England. Newton was shown on the reverse of the notes holding a book and accompanied by a telescope, a prism, and a map of the solar system. A statue of Isaac Newton, looking at an apple at his feet, can be seen at the Oxford University Museum of Natural History. A large bronze statue, Newton, after William Blake by Eduardo Paolozzi, dated 1995 and inspired by Blake's etching, dominates the piazza of the British Library in London. A bronze statue of Newton was erected in 1858 in the center of Grantham, where he went to school, prominently standing in front of Grantham Guildhall. The still surviving farmhouse at Woolsthorpe by Colsterworth is a Grade I listed building by Historic England through being his birthplace, and where he discovered gravity and developed his theories regarding the refraction of light. The Enlightenment. Enlightenment philosophers chose a short history of scientific predecessors, Galileo, Boyle, and Newton principally, as the guides and guarantors of their applications of the singular concept of nature and natural law to every physical and social field of the day. In this respect, the lessons of history and the social structures built upon it could be discarded. It is held by European philosophers of the Enlightenment and by historians of the Enlightenment that Newton's publication of the Principia was a turning point in the scientific revolution and started the Enlightenment. It was Newton's conception of the universe based upon natural and rationally understandable laws that became one of the seeds for Enlightenment ideology. Locke and Voltaire applied concepts of natural law to political systems advocating intrinsic rights. The physiocrats and Adam Smith applied natural conceptions of psychology and self-interest to economic systems, and sociologists criticized the current social order for trying to fit history into natural models of progress. Monboddo and Samuel Clarke resisted elements of Newton's work, but eventually rationalized it to conform with their strong religious views of nature. Hey everyone, I hope you enjoyed the video. If you did, please don't forget to give it a thumbs up, subscribe to the channel, and ring that bell to stay updated on all our latest content. Thanks so much for watching, and I'll see you in the next one.